So we want to find the vertical asymptotes of these three functions. Now it's not anything new, we've already done this, we just didn't know it yet. So when we looked and tried to find the domain, we basically were also finding what the vertical asymptotes are. So what does that mean? So for instance, in f of x equals x over x squared minus 1, I know that the denominator can never be 0, ever. So I'm going to go ahead and I want to solve that for 0. So I'm going to get x squared equals 1, and then I get x equals plus or minus 1. Now, normally we would say the domain is anything except plus or minus 1. Well, guess what? That except part, that is your vertical asymptote. So in this case, we would have a vertical asymptote at x equals 1 and at x equals negative 1. So now what about the next one? I've got x squared minus 1. Now it's a little different here. When we do these, we have to take into account the numerator when we're talking about asymptotes. So I've got asymptote, and so I do have, this is important. The numerator is extremely important. So this time I'm going to rewrite the whole thing. When I factor the bottom, I get x minus 1 and I get x plus 1. Now if you remember, anything over itself is 1. So I'm going to cancel these out, leaving myself a 1 in the numerator. And now I'm going to try to find out what is my vertical asymptote. Well, I'm going to take the denominator and I'm going to set it equal to 0. And I'm going to find that x equals negative 1. And that's going to be my vertical asymptote. Now, on the last one, I've got h of x equals x minus 1 over x squared plus 1. Well, is the denominator ever going to equal 0? And the answer is no, it's not. So if it can never equal 0, then it's not going to have any vertical asymptotes. So the answer is none.